Hi there, welcome back. Welcome to another video in the series for the restoration of the SABA Breisgau 8. When I finished the last video, I said I was going to focus on the audio stage. That's what I usually do with these things. I'm going to look at the audio stage from the audio input. And in our case, we're using the inputs at the back. We've got two. We've got the gramophone input and we've got a tape input, and follow that signal all the way through a preamp tube, which is the EF86 in this case, and then the power tube, which is the L84, and all the switching that occurs there, and all the tone controls, and all the tone blending and modding, and all sorts of stuff that happens on these radios. These are quite complex. They do go to quite a lot of effort to get the right tonal mix. They have the so-called psychological tone loudness control, which means that your tone shape is different depending on what level of volume you use. Generally, when you lower the volume, you get more bass. That's usually how a loudness used to work, or does work. So these guys go into a lot of detail, and it's taken me a while. There are a lot of components I had to look through, and I found one other problem, well, one other challenge. Before we go on, I'd like to invite you to visit this video's sponsor, PCBWay, who are a true one-stop PCB prototyping company supporting all types of available PCB services, including standard PCBs in a variety of cool colors, advanced PCBs, flex PCBs and more. And they also provide a PCB assembly service, which includes design with their PCB design service. And the price is $5 for 10 boards and build time of 24 hours. You can't go wrong. So visit them, you won't be disappointed. The schematic, which I believed was the same as the Meersburg, is not. In fact, this radio is neither identical to the schematic I have for the Meersburg, nor is it absolutely correct according to the Breisgau 8 schematic that I've got as well. There are slight differences. Now, this is pretty normal. These guys used to make small changes, and when you look for a schematic on the web, you're not absolutely certain you're going to get the one for this particular series of chassis. The changes I've detected so far are minor, and I will point them out on the schematic when we go and look at that. And then I will show you the work that's been done. I will tell you what I've discovered and what I've repaired. There are a couple of mechanical repairs that I had to do as well. And then we will do a test and see how the audio amp works. All right, let's get going. When I was working on the original schematic, which was this Meersburg one, as you can see here, I did all the checking of power connections and B+ connections and all that sort of thing on the Meersburg one. And then I was at this stage here, and I noticed that something was wrong. I wasn't being able to measure the components or see the components that are on the schematic. In other words, I was noticing that there was a difference between the schematic and the actual radio. So I pulled out the Breisgau schematic just to see whether there was a difference, and indeed there was. If you look here, over here we've got the top end of the volume pot goes through a 200k resistor and a 100 picofarad capacitor to this first offshoot over here. And if we look at the Meersburg, we've got the top of the volume pot goes through a 50 picofarad capacitor to this offshoot here. There is no 200k resistor, and of course when you're starting to measure components at a particular joint point in the radio and you find a 200k resistor that's not on the schematic, it sort of throws you a bit. But I discovered that the audio section matched this one, so I started doing all the painting on this one, and in fact rechecked everything to make sure that it corresponded to this one. There is one component here that's there, but it's a different value. It's a 10 mega ohm resistor, and on the Meersburg, it's a 10 mega ohm resistor. So I had to make a few notes on here, and then I noticed something else. So I went through this whole thing on the Breisgau, going through, and I got to the feedback circuit over here. Now this feedback circuit, the way it works is this. If we look at the schematic generally, what we've got is we've got to look at this logically, right? You've got an audio signal coming in here at 0.3. So it comes in here, or it comes from the outside. So if it's from the outside, it's the gramophone input, goes through a 50k resistor and joins this 0.3. This 0.3 is your tape input, okay? Now this is basically the same except there's a 50k resistor in between, and that goes to the switch over here. This switch is what switches between pickup, in other words gramophone or pickup, or radio. And so if it's down, it's making this contact and it takes your audio that you're feeding in. If it's up, it's going to feed through to the audio circuit the audio signal coming from the radio section. So that's what we're interested in, this point from here to there. So it goes in here, and here we notice there's a feedback. This signal goes back and it goes to this point over here. Now what this is a tape out. In other words, if you look at this switch here, this point of the switch is the one that gets all the audio that's coming in, regardless of where it's coming from. Whether it's coming from your gramophone, from your tape input, or from the radio, it meets here. So they've taken from this point the signal to that point there, reference to ground, so that's your tape out. So forget about that for now, that's obvious. And then the signal goes through and it gets to the top of the volume pot. Now here's where things get a bit crazy. If we forget all about this stuff, all you've got is a volume pot. This point generally would be ground. So this would be a simple volume control sort of potential divider with the wiper going to the input of your preamp tube. Fine. That capacitor there blocks it from there to there. That's fine. What we have here is a whole lot of other stuff. And this other stuff is tone shaping. So from the top, you've got to here, to this point here, which is somewhere along the wiper. It's a fixed point along that resistance of 1.3 meg. I'm not sure, but I think it's sort of at 700k. And this one's at about at 250k. There's another one there. So these components in between will serve as deviations for the audio tones for the various frequencies. For example, we can see that bass frequencies have a problem going through here because there's a capacitor. Capacitors don't like bass. So this would be a bleed of treble, and so on. So this is tone shaping at its best, and I've explained a lot of it in, I think it was the previous to last restoration I did. I went into a lot of detail, so I'm not going to go into too much of that now. But all this is doing is toning, shaping your tone, depending on where this wiper is. If this wiper's down near the bottom, you've got low volume, but there's a sort of escape route down here to treble frequencies, so your sound is a bit more bassy, and it makes it sound like it's louder, so it's sort of your loudness switch. There's all sorts of effects that go on here. In fact, this one here actually has a point, goes to a point here, which is music or speech. So even that is switchable. Now the challenges start here. This music or speech, which is one of the, or two of those piano keys at the front, aren't actually switches. They are relay activators. So this switching acts with, is operated by effectively by a relay, by a solenoid. And the same applies somewhere here, over there. So this all affects how you're going to hear your sound, whether it's going to be more musical or whether it's going to be more tempered towards the audio frequencies. And the other effect on this tonal shaping is your feedback loop. Now the feedback in this case, usually it's a resistor capacitor network from your output. Now in this case, if we follow this line here, it goes to here, there's a capacitor in parallel with a resistor. There's one that goes down here to a music or speech, so that will affect where the tones go. There's a dual speaker here that's switched in by that switch as well, and it goes on and it goes to here, and again we've got another switch down here with the capacitor to ground, and it doesn't actually go to the output. Generally this feedback comes from the output, which is this side of the speaker, because this side is grounded. What they've done is they've actually put another winding on the output, so this transformer has got two secondaries. And this, the effect of this is that whatever music, whatever sound, whatever signal is induced on the primary here goes to that secondary, but it also goes to that secondary. And so they've used the signal from that secondary, because you notice this one goes to ground, as your feedback path to allow you to do feedback of that signal. This is basically a closed feedback loop. And that helps you to adjust the tone shaping that you're going to have passing through the preamp and the power amp. So you see, it is a feedback loop. The difference is they haven't taken the signal from there, which they would have done normally on most cheaper radios, and some of them not so cheap. They've actually gone so far as to put another secondary on here. That is really cool, man. That's cool. I like that. The other thing I like, well, the other thing I've noticed, is this thing has got a switch, a speaker selector switch. And the radio has got 2 points where you can get a speaker signal from. One is a 3-connector socket on the top of the chassis, and it's got 3 pins, 1, 2 being ground, and 3 over here that goes to your tweeters, your high frequency speakers, or more like mid-range to high frequencies. Now we've got a radio without any speakers, so we don't have to worry about that. And the other one is simply an external speaker connector with ground and the external speaker. So this is called 1, and well, I think it's actually the other way around. I think that one there is 1, and then 2, and you can actually have the middle position where the signal is going to both 1 and 2. So in our case, we're going to be sending it only to this external port or the external sockets. So that switch has to be working, and that switch was messed up. That switch was bent. This thing had fallen, and it had bent, and it had basically ripped the sliders. That's those 2 sliders on there outside of the contacts. So I had to remove it, bend it back, clean it, and fit it back together. And that was actually quite easy. It was a lot less difficult than I thought, because I realized the wafers at the back, the switch wafers where all the contacts are, actually slide out backwards from the holder, from the metal body of the switch. So that was quite easy. Okay. This thing here had a 470 nanofarad capacitor, a huge capacitor over here. And I had to go look at, basically I had to look at photographs of the underside of the radio just to make sure that I wasn't seeing things. Because what they have here is a 500 picofarad capacitor. And this 470 nanofarad is 1,000 times bigger. So with that thing in, it would have drained all the sound to ground. It's almost like a short circuit to ground. I don't know who the hell put that in, but if they did, I'm sure it hasn't worked. So I removed that and replaced that. I've replaced all these capacitors. This one here is the main one that basically feeds the power tube. This was the leaky cap, the death cap you've got to be careful with. Actually, the death cap's something else, don't worry. This is the main one you have to look at. Make sure you don't, that's not leaking, because that'll make that tube run away, pass too much current, overheat your transformer, and bad things can happen. And then the other one, which is interesting, and I've just realized it's not painted. It's got to be painted. This one here, yeah, this one here is actually a capacitor with a shield around it. So this capacitor has 3 pins. That one, and a shield. Now, what you do, can't get these anymore, so I build them. And I build a capacitor I make one up by taking, in this case, a 22 nanofarad capacitor, making sure the 2 connections are heat shrunk so they don't short, and I wrap the body with aluminium tape, and then I wrap a wire around that tape, and that's your shield. And then I put heat shrink. I'll put a link above because I've done a video on how I build one of those. But that's just to avoid noise pickup, because this is effectively the most sensitive part of the audio circuit. Low signals can go on here. Anything that gets picked up here, if it picks up hum, if it picks up noise, it'll be amplified and you'll hear it. So it's a good thing to have that thing properly shielded. So that was done. The other thing I had a problem with was the volume pot. The volume pot itself was completely jammed. I couldn't move it at all. So what I had to do is I had to take it out. It's not that difficult. It's actually a lot easier, again, a lot easier than I thought. Take it out and disassemble the whole thing. Clean each part meticulously with alcohol, and then leave a little bit of some lubricant. Put it back together, and it's working perfectly, which is great because you can't get these pots anymore. The other thing I can advise you to do is to be very careful when you dismantle this thing, because it has little carbon pads that are the ones that actually slide on those wipers and tracks, and they're very small. They're dark gray or black, and when one of them jumps out, you have a hell of a job trying to find it on the floor, which in my case, wooden floor, dark wood, and my knees are still hurting. But I found it and I put it all back together. So that's cool. The other one that was a little bit jammed was this guy up here, but this one was easier. I could actually I unjammed it without having to go to too much extreme. Just in situ, and I managed to get this thing cleaned up. So basically I've got this whole thing working. Now, one thing to notice here, you remember that I said I wasn't going to do this power supply. I wasn't going to focus too much on this power supply. This is the power supply that drives the automatic tuning, but it also provides, in fact, down here, it's also a bias supply. It's a bias supply for this tube, this one here. If you notice, this wire that's coming down here comes from, if you follow that, goes through a 2 meg resistor, comes down here, down here, down here, down here, down here, and to there. So it's a pretty well filtered low voltage supply. And in fact, on the Meersburg schematic, it tells you what that voltage is supposed to be, and it tells you that at the tube it should be minus 1.3 volts. Minus, why? Because you need a negative bias. If your cathode is at ground, 0 volts, you need a negative voltage reference to ground to shut down this tube to a controllable level so that current doesn't just go whoosh, and blow things up. So this is, well, one of the dangerous issues. I had to make sure that this thing was not messed up. So what I did is I switched everything on with no tubes, and I checked that my bias was there, that there was a negative voltage there. Indeed, there was. It was at about minus 1.6, which is great. More than 1.3 or less, more negative than 1.3, which is even better, means it's more controlled. So I was able to check that as well. And I've got to tell you, I have tested the audio, but I'm going to demonstrate it for you. I'm going to feed a signal in here, whoops, and I'm going to show you what the result is, and we'll see that on the scope. First of all, here's the volume control. It's rotating very, very smoothly, no problems at all. And that is the speaker selector switch, which is now working fine. That black capacitor, that's the shielded capacitor that goes from the wiper of the volume control to the grid of the EF86 tube. And basically the rest, all the yellows you see there, are capacitors I've changed. There are still quite a few I haven't. There are a few electrolytics here that aren't pertinent to the part of the circuit that I've worked on. As I said, I'm working only from the input. You see there on the right, you've got the 2 tags. That's for the pickup input. That DIN socket on the left is your tape input and output. And we have the speaker out over there. And also that little socket at the bottom, 3-pin one, that's also the speaker out for the internal speakers. So that'll be speaker set 1, which we're not going to use. Everything else, what else have I changed here? I'm just trying to think. It only needed capacitors in this part of the restoration. Everything else seemed to be okay. The values seem to be fine. There is one more capacitor that I've changed, which is that one there right in the middle. It's the electrolytic. It's the cathode bypass capacitor for the power tube. So I think that's, what is that, 100 microfarad or 47? I'm not even sure now. So basically that's it. We're getting on quite nicely. This was the, I think I said the other one, but this is the tone control that was stuck. And it is now moving quite freely, nice and smooth. And other than that, the job goes on. All we need to do is put a signal in there. I'm going to feed a signal from the signal generator. I'll have the output going to the dummy load switcher, which allows us to either hear it on the speakers or see it, or just pass it through a dummy load so we don't have to hear the noise. We can then also see it on the scope, And there's one other thing I want to talk about here. Is you see those two crocodile clips? They're actually going to the sound card, the input of my PC, because I want to talk a little bit about the Visual Analyzer software that I'm using, which does boat plots, frequency response plots. And that will be something that I want to talk about because I'm going to do a little project to create a buffer or interface for that. So let's see how this operates. I think we're ready. I've got this thing on pickup input. I've got the scope on connected to the output. I've got speaker. Let's put it on speaker for a start. I've got 1 kilohertz sine wave. Let's make this 100 millivolts RMS. Volume, actually it's on max. Let's leave it on max for now, and I'm going to switch it on. I've got 2 lamps on, so this is sort of half limit, and the on-off is here. The light came on for a little while and then dimmed. This dial lamp is on. That one's burnt, obviously. It's drawing 150 milliamps. Let's see if we can hear anything. Oh, it would help if I put the output on. Okay. Yeah. You know what this is? Just a little blab. When you're dealing with high voltages thrown around here, and you're putting things on for the first time, in this case it's the second time, because as I said, I have tested it already, I still get nervous. And that's when you make mistakes. You've got to be very, very careful. So, as we can see, there's our sine wave, and I'm going to put it on dummy load. It's on, let's put it on 8 ohms. If I put the volume up, beautiful. It's a beautiful, beautiful sine wave. And we're at about 3 volts peak to peak. What is that? 1 volt RMS. Let me keep going. Oh, that's on maximum now. Remember, I've got this thing, the signal generator is producing 100 millivolts. I'm going to drop the volume, put it up to 200 millivolts. I want to see where it starts clipping. We're now at 2.7 volts RMS and we're still not clipping. I'll put that at 300. And we're starting to clip there. Now remember, I've got the restriction on, so I'm going to remove some more restriction. I'm not going to put it straight through. I'm just going to put 2 more light bulbs in series. So we've got now 221 volts going in. It's drawing 180 milliamps. And it's clipping sort of there. What is that? 3.5 volts? 9, 10 divided by, what is it, 8? Not much wattage. Again, as I've said before, I'm always surprised by trying to calculate the actual wattage, clean wattage coming out of these things. And this is very deceptive. And I'll tell you why. It's very deceptive because when you hear one of these things playing, it is extremely loud. It is really, really, really loud. So, again, I have no idea why some of these power calculations don't make sense to me, but we shall see. Now, I'm at the, what is this, the base control. If I go the other way, I get no effect really, because this is a 1 kilohertz sine wave. If I go to the treble control, yeah, we start seeing an effect. 1 kilohertz is already sort of in the treble range of this thing, and we do see an effect. I wonder, I'm going to do this again. I'm going to drop that, and I'm going to go up to maximum volume again, see where it clips, because I'm not sure that I had the treble on maximum. So let me try again. Yeah, it's about the same. See that? Now it's clipping on both ends. So the distortion there would be pretty bad. We've got some distortion on the lower end of the waveform. That's where it starts distorting first. But if you look at that, that is a beauty. That is a beauty. And then of course we've got things like music, select music, and select speech. It's So it obviously affects the 1 kilohertz range. You know what? I'm not even sure which one I'm pressing. I'm just alternating between them. But we can see the difference. And of course, another thing that this does is when you put it on music, it switches in those the two side speakers that the radio would normally have, which in this case I don't have. But yeah, that's it. One more thing that I want to do here, and that is I want to show you what happens with the bandpass, with the frequency response. And the best way to do that is to use this Visual Analyser software. Let me show you that. Now let me explain first of all what this is. This is the VA software, Visual Analyser 2020. It's free for anyone. You can download this. Just look for Visual Analyser 2020 and you'll find the download site. I've used various versions of this. This one certainly is the most complete. What I have is the signal from the speaker going into the line in to my sound card. It happens to have line in, otherwise it would be the microphone in. And I have controlled the volume. You look at this here. I've controlled the volume so that it doesn't overload the input. Now obviously I've got no attenuation going in, so I've got to be careful about the level that I'm pumping in here. The most this can take is about 1 volts RMS or thereabouts. So I've kept it low on purpose. Also, I'm able to make the volume on the radio at maximum, so I don't have those you know, those taps affecting it. This is as clean as it's going to go through. And as you can see, the sine wave I have there is a 1 kilohertz sine wave, and we've got a you know, you've got a spectrum analyzer here as well. There's a lot of noise on the low frequencies. This is mains, hum, and everything else in the workshop. So this thing is by no means a high fidelity thing. And you can do quite a lot with this. You see, we've got some distortion on here. We can see that. That's not unusual with tube equipment, no matter which you're using. So I'm not surprised. But what you can do here is actually do a sweep. And I'm going to program the signal generator to do a sweep. I think I've actually got it programmed. Sweep starting at 20 hertz, finishing at 20 kilohertz, and I've got a 6-second time limit for that sweep. And we see it sweep across. Now what I can do here is I can make this hold. This is what I do. I hold it, sort of, it's a peak hold, as you can see, on the spectrum analyzer, and this just keeps sweeping and improving, as you can see here, that the curve. Now, what does this tell us? Well, it tells us quite a lot actually. It tells us that for some reason, I think we've got speech selected here, and speech means that it's dropping off some of the high frequencies. That's why it's sort of down here. And then it gets to about 700 hertz. That's your peak. And then it starts coming down again. Okay? Now that is the curve for this particular setting. Now if I take the hold off and I select something else, I think we had the other one on. I'm not sure. Let me try speech. I think maybe we had music. Let's see. This is speech. No, that's what we had. Let me try music. Okay, so I've got to release the hold function, the peak hold, and I'm going to select music. Let's see if it makes any difference. You know what, without taking screenshots of this and putting one on top of each other, I'm not really sure. I'm not sure at all. Now, what I do know I can do, for example, I've got my bass set to the one end. I'm going to set it to the other end and I'll release the hold. So I change the bass setting and see what happens. Now I've put bass on maximum, and you can see the bass frequencies are now higher. It's shifted that way. Okay. Now with the bass on maximum, let's see what happens if I put the treble. Remember, I think I had it on maximum. I'll put it on minimum. and release the hold again. See what happens. Well, yeah, it's certainly making a difference. So your bass is very strong and your treble, it's just cutting it right down. Now, this is not calibrated. In other words, these dBs here mean nothing. I'm not too interested in what they actually read, but what I do see is that it does attenuate a lot, and I can see that on the scope as well. It attenuates a hell of a lot. Now let me put the treble back up. Let's see, we had bass on maximum, treble on minimum. Let me do it the other way. Bass on minimum, treble on maximum. Let's see what that looks like. We push hold. There we go. Brilliant. Now, as I said, this is not calibrated, but what I do know is that this thing is cutting high frequencies quite dramatically, and I can see that on the oscilloscope itself. So maybe these dBs are real. This is 0 dB up here, so it's sort of at -6, and it's going down to -36 at 20K. At 10 kilohertz, you're down at -24. So there's a dramatic drop in frequencies from the 1 kilohertz to 10 kilohertz, which is a little bit surprising. So I'm not really sure what that means. And quite frankly, I'm not going to judge it based on what I see here. Let me stop the sweep and just leave it as a sine wave. Now, as you see, if I up the volume, it's on maximum. But if I put that thing to, it's at 20 millivolts. If I put it up to, say, 60 millivolts, and I go up to high, I start clipping because this is higher than the sound card will take. Okay? So there I'd have to be very careful. And what I want to do is I want to build an interface which will do various things. One of them is, let me get rid of hold here. It'll get rid of this noise over here and probably over here too. The sound floor, the noise floor is pretty high. The interface is very simple. I've actually did a little project and I've ordered PCBs. So I will be doing a video on that. And what I want to do is I want to be able to take the sound from the, or take the signal from the speaker output. And the same way that I do with the scope, I want to be able to see it on here. I'm not interested in the scope function here. I'm only interested in the spectrum analyzer, which for a audio range from 20 hertz, well, actually this goes from 0 hertz really, from 10 hertz to 20 kilohertz, the sound card can handle it quite well, and it gives me an idea of what I'm seeing here. I do know, for example, these two distortion figures here, this is at 2 kilohertz and 3 kilohertz, so this is the second harmonic and third harmonic. I do know that they are independent of volume. Now, when I do that, this distortion that you're seeing here is not on the speaker, not on my radio, it's actually the distortion that the sound card is seeing. So, again, one has to be careful. And there we go. I've got rid of that distortion simply by dropping this level. So, this could all be distortion that I'm actually getting from the sound card. But as I said, when I use this, I'm more interested in doing frequency plots, Bode plots or Bode plots, and than anything else. So this works quite well, and I'll be doing that interface, which will have a switched function for attenuation, so I can do a 10 to 1 or 100 to 1, and I can then, you know, sample bigger signals without it overloading the sound card. Should be fun. So that's it for another video. I'm going to stop here for now. What do I need to do next? Well, I'm happy with the audio section. I need to just check what this thing sounds like because I'm not too happy with the way this thing cuts off the frequencies. This is by no means a flat amplifier. The possible answer could be that with the speaker arrangements that you put in, it sort of compensates for that loss of trebles. On the other hand, it could indeed be some capacitor that I haven't found, which is unusual, but we'll know when we start playing some real music through here. But anyway, the audio section's done. So what do I do next? Well, I'm going to go back and I now will go into the radio section, do some recapping, and probably come back to you when I have the AM bands working, for example. And then we've still got the FM bands, and then we've still got the automatic tuning, and there's quite a lot to do here. As I said when I started the series, I might not be doing this continuous. A couple of things have come in that I might do in the interim. But this is what I'll be working on. So this is what we'll see for now. Once again, I want to thank you for watching. I hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Links are at the end of the video and in the description below. Thanks for watching. Bye for now, and stay safe.